All right, class, this is the second part of chapter 36. And in the second part, we're going to look at how we can model population dynamics in human populations. And if we model the growth of the human population of the planet, we can see that we are right now in an exponential growth model, right? Remember that in an exponential growth model, we don't see a big rate of change. Let me grab there we go. Notice the slope of the line through much of human history, at least back to where we can estimate. Of course, all of these are estimates. We don't have good models from the 1500s, of course. But up until about 1900, we had a fairly slow growth curve, right? The rate of change in our population really wasn't that much. However, if we notice in this last century, 1900 to 2000, we had a tremendous growth in population. Now, most population demographers estimate that we're going to level off around 9 billion people. So if we look at the rate of change of our population, it is starting to slow. So the rate of increase is starting to slow a little bit. But we're still increasing. It's important to understand. So we're still increasing our population, but the amount that we're increasing that population is starting to go down a little bit. So most demographers think that we're going to start to level off around 9 billion as long as there's no major changes to our models. We can see these rates by studying what's called demographic transitions. And this is when we model, or we basically plot, birth rates and death rates against one another from high to low. And this is typically due to economic and social development. So I think this is the United States. If it's not the United States, it could be. So let's look at what happened in the United States over the last year. And of course, we can see that there's estimates going after 2020. So if we look at the United States birth rate, so the blue line is the birth rate and the red line is the death rate. First of all, I want to point out what happened here. What do we think happened here? So this is around 1910 to 1920. Well, pretty important one. There was a World War I, was a big event, right? That killed lots and lots of people. And then also, unfortunately, I don't really want to bring it up right now. It's not very fun to think about, but we also had a pandemic, right? We had the Spanish flu in 1918 that killed a lot of people. And so those two things combined together over that period of time dramatically spiked that death rate in this country. So if we look at birth rates, and if we were in class, we would show this. If we were doing this together, what I would have you do is all write down how many children your grandparents had. So for example, let's see here. My mom's parents had 11 children. She was one of 11. And my dad's parents he was one of 4. So they had 4 children. Whereas they only had 3 children. It went down, the birth rate, just from the boomer generations, right, to the greatest generation, right? So our grandparents would be called that generation is not my opinion. It's just the name of their generation. It's called the greatest generation. To the boomers, that birth rate actually went down just a little bit. And it's going down even more dramatically now. If we were to look at how many, say 40-year-old women in the United States, how many children do they have on average? It's extremely low compared to our grandparents. So the birth rate for a country, and especially ours is a great example of this, or I shouldn't say great, but a typical example of this is that the birth rate, as basically economic prosperity comes, levels of education, increasing rights for women, and so on, female empowerment, as that increases, the birth rate is going to go down. So if we have this blue line going down, that's really an economic and social equality indicator for a population. Now, ideally, the death rate should also go down. So this has to do more with increases in public health initiatives, social welfare programs, lack of political and social instability, and so on. And so this is what we see in a population over time. And lots of countries, we're well past this demographic transition. And this is also why we have so many boomers, right? We have right now, the boomers are from, I want to say they're right now I should know this. Let me just Google this really quick. I don't know if there's like hard numbers on boomers. Age range, here we go. baby boomers were born between 1944 and 1964. So they're currently between 56 and 76 years old. And this is because during that time, that post-World War II time, the birth rate essentially stayed the same, but the death rate decreased quite a bit. And this is when we're going to get that huge increase in a population. And this is what we saw in the United States as well. So here, what I want you to compare are developed nations compared to developing nations. So if we were to compare, we're comparing the birth rate and the death rate. So if we look at these four numbers here, we can see that in developing nations, again, like let's just think about the United States and most of Europe, the birth rate and the death rate are almost equal. And that's bad news if you want a population to increase. Basically, you need a rate of increase of at least 2, because that's your 2.0, not 20, 2.0, because that's basically the replacement value, right? If 2 parents have 2 children, that's the minimum number of children that they need to have in order to replace them when they die, right? So anything below 2, we are not at replacement levels of population growth. This is why if it wasn't for immigration, for example, the United States population would actually go down. In less developed nations, so in developing nations, now compare these numbers, right? 20 versus 7.4. The rate of increase is huge. And this is why we're seeing just enormous increases in populations. For example, in many parts of Latin America, in Africa, the number of young people in Africa is crazy. Like they're going through this demographic transition right now, right? So many countries in Africa are in this early kind of phase of this demographic transition. So in order to kind of graph this and visually represent this data, we have what's called, what's the name of these? I think I have it on the next. Do I have a age structure? I've always called these age structure diagrams. Oops, sorry. Okay. And what these age structure diagrams are really complicated, but let's just break this down and see what it shows us. So first of all, this is for a given year. So again, I'm pretty sure this is the United States in 1989. And notice that the left side of this curve is male, or this graph, I'm sorry, and the right side of this graph is female. The x-axis represents the number of people in the millions. So right? 5 million, 6 million on that side. So the x-axis is the population of males, females, or both. It turns out it's both, right? Because the right side is female and the left side is male. Now, what does the y-axis show us? Well, the y-axis shows us the age of the population. Right? Because the y-axis, as that y-axis increases, we can see that the population, or I'm sorry, the age of that given population increases. So this is telling us, this particular type of graph is telling us a lot of information. So from this graph, we can see, notice that we're kind of breaking down, we're putting our ages into buckets, 0 to 4, 5 to 9, and so on. It looks like every 5 years, basically, or every 5 years. We're creating a little like a bucket to put people in. So if there's approximately, if we were to look, so what are we doing here? There are approximately X million females aged 10 to 14. So if we look at 10 to 14 and we look at females, so we're on the right side. So we're looking at female citizens of the United States that are 10 to 14 years old. There are approximately 5 million of them. Try to do that for males, age 60 to 64. So males is on the left, and here is 60 to 64, and it looks like about 1. So the right answer here is A. So you can see that it not only tells us where our populations are, but the amount of people, for example, that are in certain age categories. So what do you think these age categories represent? Like, what is the purple, the pink, and the blue? Well, hopefully you recognize that the pink part of the graph are people of reproductive age. Right? These are post-reproductive age, and of course these are generalizations. And these are pre-reproductive age. In other words, we can see, right, this generation more or less gave birth to this generation, and this generation, again, more or less within a range, gave birth to that generation. So it's actually showing you the different kind of age structures within a population. Oh yeah, I don't think this is the United States because it's only 83 million people. We have way more people than that. So this isn't the United States. I wonder what country this is. Oh, I also know this isn't the United States because ours looks different. In 1989, we would have not had this many young people. Okay. Population age structure. Sorry, this question is kind of a messy question. So why does the yellow highlighted section shift from the first to the second? Oh, this is a good question. Okay. Note the years. I'll give you a minute to figure this one out. So let's see. So from 1989 to 2012, we're looking at what? About 20 years, a little bit more than 20 years. So this population of females is now this age. So in 2012, the adult female population is smaller. No. In 2012, the population is smaller than the population of girls. This is true. Although this is true, it doesn't answer the question, right? We're asking why the shaded yellow part shifts. In 2012, the adult female population is larger than it was. Well, again, also true, but doesn't answer the question. 2012, the population of girls is larger than it was in 1989. Again, also true, but does not answer the question. The reason that this yellow bar or this shaded yellow area switches or shifts, I should say, from one graph to the next is that these girls, right? So we're looking at girls that are, so we're looking at females that are 14 and younger. By 2012, they're here now. They're from ages 39, it looks like from 25 to 39. So of course, over time, right, we're looking at how this population moves through time. So this allows us to predict what future growth patterns will look like. So here we have a population where we have very, very few old people, right? Older people. Oh my gosh, I'm almost in this group. Oldish people, and lots of young people. And so as these young people move through time, as we go from 1989 to 2012 to 2035, we can see that the population of this country is going to increase dramatically. It almost doubles, right? It goes from 83 million to 140 million in 40 years. About a little over 40 years. That's a dramatic increase in population for a country. And so that has all kinds of ramifications for policy, right? If you're leading this country and you're the president of this country in 2012, you're not necessarily going to make policies based on a shrinking population. You're going to make policies based on an increasing population. So we can see this, right? If we plot the age structure of different countries on the planet, we can see what countries are predicted to expand rapidly, expand slowly, stay stable over time, and believe it or not, there's lots of countries whose populations are not only declining but declining really rapidly. Many countries in Europe, their populations are decreasing. It's a huge problem for them. Japan is also another example of this. We're also decreasing in terms of our rate of growth, but it's not nearly as dramatic as, again, these European countries and Japan. On the other hand, again, a lot of African countries and Latin American countries are going to have explosive growth over the next 20 to 30 years because they have so many young people compared to the older segment of their population. And then we have, of course, something somewhere in the middle where we see a slow expansion of growth, right? So we don't see large bulges kind of in the age structure. And then, of course, we have lots of populations that are staying relatively stable as well. I think if we had to predict where the United States is, we would be in this chunk. So is this population growing, declining, or stable? So hopefully you recognize, again, if we were to look at roughly speaking, the reproductive age of this country and the pre-reproductive age of this country, in other words, the children, this is a dramatic decline. And this is a big problem so we're looking at Japan right now. This is a big problem in Japan. Basically, people aren't having children. And the number of children that they're having per household is dramatically lower than it used to be. And this is going to cause the population of Japan to shrink. And this is, again, a big issue for them. So the correct answer here is declining. B. All right, another question for you. Based on the age structure diagram, how should the government invest its resources for 2050? So looking ahead, so hopefully you recognize that they definitely don't have to build more schools, right? They have fewer children now than they did 20 years ago. So they don't need more schools, right? They need less schools. In fact, that's probably a problem for them. They definitely don't need more housing, because again, their population is declining. They need to invest in healthcare. This is a big issue in the United States. In fact, before I left Wisconsin, I was on the nursing, I sat in a lot of the nursing meetings, and they were talking, this one person came in and gave a talk on the need for basically long-term healthcare, hospice care, nursing home care, and basically post-hospital stay type care, assisted living, that kind of thing. In Wisconsin, and the numbers were mind-blowing. Like the number of the number of old people in Wisconsin is growing so rapidly, and there's just no replacement population, right? Everyone, all the young people are leaving, and they're not having, the birth rate has dropped dramatically, and so there's not only people that aren't there to take care of them, but they don't have the infrastructure to take care of them either. So this is a big problem for countries that have declining populations, because as these populations age, there's no one there to take care of them. There's no one there to take their jobs and replace them in the workforce and generate revenue for taxes to basically create the Social Security structures that these old people need to be taken care of. So, I think these are the last couple slides here. We estimate that we're going to have around 9 billion people in the next 20 or so years. And the question that as a planet we need to ask is, do we have the resources? Are we hitting our carrying capacity? And what does hitting our carrying capacity look like? We don't have right now, given current farming practices and current food choices, we don't have the capacity to support this many people. And I think that it's important to point out that it's really not the number of people. I think this is something that irritates me. A lot of people tend to think that the solution to this is to not have as many children. And that's really not true. There are plenty of households and plenty of economies around the world that have children and have large numbers of children, but their footprint is quite a bit smaller than that in the United States. So if you are in the United States and you only have 2 children, but you live in a 7,000 square foot house and you eat meat with every meal, and all of you have a car and you fly everywhere and you go on vacations and so on, you have a really large footprint in terms of the environmental impact that you have. So it's not just the number of people that we have, it's also the lifestyle that these people have as well. So we use far more resources farming food to feed to animals that we then eat than we would if we were simply to grow vegetables, for example. So it's not as straightforward as just a simple population growth model. So, and this is kind of what I was talking about before. We need to really reduce our ecological footprint. We have the average American needs about 10, I think this is hectares. Yeah, I forget what a hectare is. It's like, it's some, let me think if I can, hectare to acre. So 1 hectare is about 2.5 acres. So the average American, let's say, has about 10 hectares, which would be 25 acres. So we need 25 acres of land to produce the resources that one American needs to fulfill all their needs right now. And so this is what I kind of meant when we're talking about your lifestyle really matters too, because if we're using a lot of resources, we're going to hit that carrying capacity much sooner. I think that does it. Yeah, for chapter 36, that's it. Ooh, a short one too. That was only a little over 20 minutes. Good job, Sarah. All right. One more chapter to go, guys. 37, then we're done.